Period. Now we can start. Held everything up.
Our replacement took priority.
With the switch when 3:30. Okay.
Let's adjust some stand for the.
Of course. Yeah, I will, because I moved the slides also for the recording.
But then I can move to this table then, right?
Oh, yeah, of course.
I just carry it around.
It's pretty heavy.
There you go. There you go. Don't touch it. Yeah, it was not. We talked about this. I was going to do this. Can we start? Let it go. Yeah. Had a discussion with Brett earlier that this would be more talk about what we can do with it, and we wouldn't be doing the technical things. And the first feedback I got from testing the presentation again, somebody said, "Why didn't you show me that picture right away?" Then I understood what was going on. So let's do. So Hein van den Heuvel, working with CDC for forever, in a specialized context from Oracle, from Attunity Connect context. We'll get to that slide. CDC, let me give you that picture I suggested. What it's going to do is you have your basic COBOL data tree DCL-C application. We will intercept any and every RMS call you make, pass it through to RMS to do the work. And then as we intercept the call, we will determine whether it's an interesting call and has interesting data, grab that interesting data, stick it into a memory buffer. So we will not slow your process down for IO, stick it into a memory buffer. Then there is a dedicated process that empties the memory buffer into a file. And then a lot of work needs to happen. Then that file needs to be read, and it used to be read by Attunity services and into a complete package solution that solves your business problem completely, right? But that option has disappeared, and the log now needs to be read by your tools or by Brett's tools or what we can come up with. And I will go slow on these later on, and then export it to the big bad world and be used by the script kiddies and stuff like that. Whatever, however you want to deal with the data, because apparently you cannot hire COBOL programs anymore, right? But you can hire developers for your off-premises systems. So keep your jewels on RMS, on VMS, and have the reporting and the downstream processing off the box. That's where we're going to go to. Let's open up the real start. What is it? It's a mechanism to capture data changes in RMS records, and only modify through RMS. So we have to go through RMS to be, and who would use something else? So if you patch the file, we won't see it. To capture data changes along with some metadata are stored as individual records in a local RMS sequential file. So we just keep on adding data and data and data. And RMS CDC is not associated with RMS journaling, which is a separate tool that comes with the corporate license these days. And RMS CDC is a reincarnation of the Attunity Connect CDC service. Why would we be doing this thing? And this is really should be the core slide of the whole presentation. But so very basic, what you may want to do, replicate the RMS data into SQL Server or into SQL Server or a message server. auditing who changed what where. We keep track of that data change, but we also put a process ID on it and a timestamp on it, and so you can find back who changed it at what time. Where are you going to put it on your application file? Most likely, but go ahead, put it on VMS files, accounting, sys UAF. So your accounting data, your T4 data could be streaming off box, and you can analyze it out there and slice and dice it any which way you like. If you know, accounting is great, but if you want to look for an accounting record, it only knows how to scan the whole file in one go and find that record. And if you miss it, you have to start over in the beginning again, right? So if you dump your accounting data into a SQL table somewhere, now it can do a multi-key lookup saying, find me the record in this time zone for this user. You cannot do all those combinations with accounting. SysUEF. So yeah, I know you have the tools to do that stuff right now, but you can get so much better tools out there that do automatic graphing and so on your VMS data. One suggestion I've been trying to sell, but I didn't have a good buyer, is RMS file monitoring, but at the file level, not that. So we know we have shadowing, and we know we have RMS journaling to keep files up to date, but one particular, I don't know why he never actually went through with it, but one guy had an offsite backup server 2,000 miles away, right? So we can now take the changes, and there are just records of changes, as you see. So as if I take that change log every 5 minutes and FTP it or whatever simple mechanism you come up with, send it over to the other side, I can then have a program to apply those changes on his backups. I can does anybody have a long running convert that takes 2 hours or something, or 20 hours? So you cannot do those. I could set up data capturing on my data file before the convert, take a backup, let the customer continue to work, and now my changes are being copied into my log. I convert behind his back in 2 hours or in 20 hours, it don't matter. Then I take the file offline and apply those changes in 20 seconds and bring it back online. So now I shorten my downtime for backups to a minute instead of 2 hours. Right? If that's critical to you, could be an interesting solution. I have tools that largely do that, but those are not complete solutions. They need integration services that we'll offer, or if you're smart, you do it yourself. Fine. And then one silly thing, but it was extremely valuable at one point. It was in the Attunity context. We had a file being updated and nobody knew why, when, where. So we just waited, scanned the log for the changes and found the culprit, so to speak, because we know it also knows which program opened the file. All right. So we want to give you more than just this change data capture. So the raw data is there, and that can be enough for your purposes. But Brad is thinking of and offering products to complement just that raw data and say, okay, here is a tool that at least puts it into a SQL Server, and we'll take it from there. Here's a method to put it into a message queue, and now you consume that message queue whatever way you want to deal with it. So we'll be happy to engineer the full solution based on this product for you. It is not a flavor of RMS journaling, and it cannot be. So journaling had 3 components: after image journaling, before image journaling, run unit journaling. The RMS after image journaling was not record aware. It didn't know what record you were changing. It only knew which block you were changing. It didn't even know whether you were changing a data block or an index block or an alternate index block. Your data, actual data, lives in a data block. but around it is this infrastructure. And if you went to the first presentation, sometimes one insert can create 15 writes to the file, 15 buckets are being changed, and those will all be buckets full of data going to the after image log. So a 40 byte change can make a 4 megabyte after image log. And we just had some inputs that it's just not workable in general. Run unit journaling was there to support transaction semantics. I skipped that, but actually, well, it's kind of cute. I wrote my first CDC 45 years ago on PDP-11 RSX11M to fix different problems at the time. We were not thinking about SQL servers or anything like that. We were more thinking about how can I fit 200 users on a 16-bit operating system. Worked well. Then the tool was created in 2011 when Unity wanted its Connect product to be expanded to, so it already had a SQL server, SQL ODBC connection possibility to your RMS files, and then said, I want to do more. I want to follow those files in a near real-time fashion. I want to bring that file transparently, keep a copy of the file up to date on a database server, any database server. Right? So that was 2011. We made that, and it's been running stable ever since. As long as you leave it loaded, just don't unload. That's trouble. But no, it's been running. We fixed those unload problems also. But so it's been running fine. It has a robust performance. And why are we doing this presentation here and now? Is because we finally decided to port it to x86. So this is why we're doing it now. But the technology itself is not new. The implementation details on x86 are going to be different, of course. So now we come then, so how does the intermission, how does this all fit in your VMS world? This is the picture I described earlier already, where we create the intercept and we log the data into a file and move it over outside. We'll go into the steps. More geek stuff. You wanted to know this. I know you wanted to know this. What do we write to the data file? So this is the official definition for the data file. For the change log file is more, looks nicer than this. But basically, we have a 64-bit sequence number. We have the 64-bit timestamp, a process ID, a device name, and a file ID. So we are not recording the file name because those are just long and directories and became longer, which means that that a job interpreting this data needs to remember from the open to connect that file ID with the actual file table you want to call it you're working on. And then we also, because we have it, I put in the RFA, also the virtual block number where the record lives, and then a blob of data. So there is no, why that's relevant, it's just a blob of data, so we don't understand columns, we don't understand fields or index at that level. There needs to be something, Brad, alongside that has a dictionary of sorts for you to interpret that data. Now, if you're just using that data for you as a backup or an auditing, you don't need that. You could apply that raw data as it is to your next RMS file. Why not, right? So it depends on what you're going to do with the data eventually. If it's just a backup, I was talking with Jeff earlier. Why would I use CDC? Well, he was presenting the JSON access to his file. Well, he could be generating constantly a JSON output of all the changes. Why not? And then he cannot only ask you with his REST API, what does the file look like today or right now? Or you can also say, how does this file come to be? What did you do to it today? Right? But just querying that. I'll be waiting for a demonstration later on. Should take no time at all for you to program that. So third time over, the CDC itself is just a tool. It's not very useful in and of itself. You have to do something with it. So in that simple solution where it's, well, simple for me, When you just use it to replay changes against an RMS file, nothing much more is needed. That raw data is all you need. You got your file that you're talking about, you know where you need to do an insert, an update, or a delete, and you got your bytes. What else do you need to know? So that's fine. But if you want to see who changed what in the file, then it's fairly easy. I got a Perl script for that, a Perl script to go to that raw data and report with a couple of filters for username or program name, report of who changed the record at what time. But typically, the data needs to be understood through metadata of some sort. That's the more expected usage. Which is why you haven't seen it so far. When Attunity wasn't interested in selling the C2C component as such, because they had that solution. So they had at first a Microsoft SAS integration package, where Microsoft knew how to read the changes, and later they provided this replicate tool, which is a magnificent tool, I must say. And that's still, the replicate still exists and still does support the RMS files, change files coming from Titanium, but they don't sell it anymore. But they're not removing that little slave process to read the file. And so there was a connect agent to read those changes. They're leaving that in place, best we understand. Attunity already had the metadata, just like Connex and Trifox and those tools. They all have to have a definition. The Attunity one was a nice one, a dictionary, very similar to CDD. In fact, it used the CDDL language to make the definitions. And I think what I'm going to steal from that is they have a set of awk procedures to convert any of the data definitions to XML and CDDL. So it's always useful to have. Yeah, I'll send you copies of those. That's just awk scripts.
Yeah, I run them.
Yeah. So getting towards a solution, you would assuming you have a definition of your data already. So this could be basic map files, or they could be COBOL lib files, or anything like that. And then we have to find the change logs, because those logs, we can't have them grow forever. That's one thing. So we need to flush them out and create fresh ones. And we decided to have them be local to the node for obvious performance reasons. So we're not sharing files, and that's why we have that sequence number. If we are in the cluster, we need to know who the exact order of operation, such that you don't lose a change. And the order of operation is done by the sequence number in those files. So the sequence number is, we maintain a log block, slide will come up, a log block with a log value in there, and the log value, every time a change is being generated, it's given a number consistently to the cursor, to the cluster. So if you did that, and this is back to the solution tool, that's all fine and good, and half of this group could program this. I know you can, but but there's still a lot of VMS skills involved to interpret that data. So we want to take that away from you and offer you a more integrated service to do that merging of the files and to get it out there. But I do, and I still need to find the right way, but as I'm going to share the presentations, I'm also going to share a toolkit of my RMS tools in general, and 2 tools will be there for this change data capture. A generic tool that can report and apply those changes on different files, and a generic Perl script that can help you select the data from those files. But we really don't want you to, if you want to go for it, and a team like Jeff probably will, but a normal application team doesn't want to go there. You got nothing better to do. You don't care about the actual data. Customers do.
It's not normal, so
Yeah, that's what I was
Not normal. So we need to help you with that, and that is not fully defined yet. We're still trying to come up with the right, whether it's going to be something you can buy, or whether it's most likely it's going to be a service, most likely. Okay. And that Brett already did some presentation, a couple of slides on this in the prior presentation. So look at his data there. So we're working on an OpenVMS based C2C consumer process, such that we read those files, the records are to be published. We'll do some field level transformation for VMS isms, right? Because not everybody understands a floating point the way we write it. And in the quad word time and date, you want to be in the old year, month, day, hour, minute, second. Otherwise, nobody understands it. We can, for example, translate the operation plus the data into an insert statement, and then you can run that insert against any database you like, right? We'll publish it to Windows or Linux endpoints, and once it's there, you can let your new generation programmers deal with that data and come up with whatever magic tool they pull off the web. More geek stuff. You want to know geek stuff, right? You do. I know you do. So how does it all work? Well, we have a command line tool. This is VMS after all. A command line tool where we can load that intercept. We can add or remove files, declare them to be of interest with a just a string wildcard. So you can capture a bunch of files and you can say, do I want only the current version of the file or any version of the file to be captured? And we can control the log file to create it, of course, to pre-allocate it, to change it over at a certain size. Do you want to create a fresh one every megabyte, every gigabyte, every 10 gigabyte? You choose. Do you want to roll it every hour, every day? I like rolling it every day at least. So I give it both a size, something manageable where I can copy it around when I feel like it. And I want to run it every day just so that I can compartmentalize my changes to a degree. And how many records do we allow to accumulate before flushing them out to disk? So there's a space and a time criteria to flush it out. And the status, how much work did I do? How many changes per second am I processing? That's the command line. So on that load command, we make sure that a privileged image with the code is installed. We check the RMS version for consistency. Why do we care what RMS version is? Because while most of the time all you need is the incoming call with the wraps and the fabs and the data buffer. That's most of the time. But we also offer you before images. So when I'm being told update the record is gone already, right? The update only provides the new record, not the old one. And when I do a delete in RMS context, you've established a current record. You might not even have looked at it. You can do just a find and not see the data and delete it. So we have to go into RMS and say, tell me what it looked like again. And we find the data, but that is RMS dependent. It hasn't changed in 25 years. We are not planning on changing it in the next 25 years, but we do check that it's the right version, right? Then we create a large memory buffer to capture those changes. And then when all that is in place, we juggle the page tables with the RMS vector, but that used to point to the RMS code, and we make it point to our code. And so at that point, every RMS call will go to the intercept. We better have a robust version there. And I'll call RMS onwards, of course, yes. So the RMS code that has the C2C code that has to decide whether the file that you just opened is of interest. So if it's of interest, we're going to do the getting of the data and call the real RMS, and on success move the information to the memory buffer. So we only register successful operations, and we return to the caller. The beauty of this is that there is no escaping. Whether you call systol or put directly, or whether you use DCL, or whether you use COBOL, everybody knocks on our door. Okay? So because there is an alternative, there's a system server intercept that you could program against, and which you could run before your program and then say, capture my changes. There's no guarantee that you capture all changes. This captures all changes, no exception. So the load command activates the logger. The logger watches the circular buffer in the memory and writes them out as it needs to be. And then this might be of interest. We create and roll the log file with a name that normally looks like a node name, and a timestamp. So you see already how we can then combine log files from multiple systems and tape merge them to get all the changes into order, in the right order. And so new changes get a unique every increasing sequence number. We do that in a cluster-wide log value block, so it's relatively low overhead. And the initial value is loaded from a startup, from a little control file, which when we pre-commit the changes every 200 hex, every 512 events, such that should the system go away on us, we will not hand out the same sequence number again, because we will start in the next chunk of sequence numbers. After time.
It's time to start wrapping up.
Okay, yep, you're right. And we're there sort of. So we have this file of list file of interest after an open and a create. We know which program is currently opening it. We know what the file name is. We see if it matches. If it matches, if it doesn't match, we move on, walk away from it. If it is a match, we set a flag in the FCB file control block. Snarf a bit from a VMS. Sorry, it's ours now. No, we talked about that, but that bit is ours now. And so on the next entry, so that's extra work on the open, but on the update, we need to stop now. On the update, put delete. All we have to do is take your update call, comes with the fab, follow that to the IFAB, follow that to the FCB. It's like 4 instructions, and oddly, my COBOL test program ran faster when it was enabled than when it was not enabled. I don't know why, but I'm not interested why. But you just will not notice. And I'll wrap it up with one final word: is that read more slides if you see fit. Everybody has to worry, of course, about overhead. How much does this cost? Put that in the RMS perspective. What we're going to log is a single record with just your raw data into a sequential file. That's easy stuff. And compare that, and that is the result after you updated a record in an index file where you read an index bucket, a second index bucket, a data bucket where you wrote a allocation block where you wrote another index. You've already done 20 IOs. At that point, to add a 40-byte records to a sequential file doesn't make a difference anymore. So performance is very acceptable. Let's keep it at that. And of course, any immediate questions?
It says to be activated per process.
No, no, because we don't want you to escape. You want all your changes. Yeah. Because it's an attribute, it becomes sort of a file attribute where you say this file is now being watched. Anybody opening a file, any cluster member will be watched. Okay.
Great.
Thank you, folks.